All right, for this first video on factoring, because there are quite a few topics for this one. We're going to begin with the simplest idea, which is the greatest common factor of two numbers. First of all, to know what a factor is, it means basically like a piece of something. So when you break apart a number into its pieces, you are factoring it. So if I did 12 is equal to 3 times 4, okay? 3 and 4 are factors of 12. If I did 12 is equal to 2 times 6, 2 times 6 are factors of 12. So basically, any number that number could be broken into is a factor that divides into it. So 3 divides into 12, 2 divides into 12, 4, 6, etc. So we're looking for the greatest common factor, okay? And a lot of times, the best way to approach this is by looking at prime factorization, which means to split these guys up. And you can see that if I did 2, 2 is the smallest prime. That would be 2 times 14, okay? And break this up, that would be 2 times 7, okay? So 28 is 2 times 2 times 7. 34, if I break apart 34, I get 2 times 17, okay? 2 is a prime, and so is 17. So you can see that the only factor that they have in common is 2, and that's it. And that is the greatest common factor. Now, when you're using primes for greatest common factor, you're looking for what they have in common. So if there was another 2 here and they had two 2's in common, then the greatest common factor would be 4. Okay, that's the method to find the greatest common factor. So take a look at this one, 12 and 48. Now, those of you that know, you would know that 12 goes into 48 and it goes in there 4 times, but let's pretend you didn't and you were going to use the prime method. 2 times 6. 6 isn't prime, so break it apart. 2 times 3. Okay, so 12 is 2 times 2 times 3. 48, I'm going to go over here with 48. 48 is 2, which is prime, times 24, which is not. 2 times 12. And you might notice it right then and there, like, oh, wait a minute, 12. Okay, 12 is not 2 times 6, 2 times 3. Okay, so just to understand, we're looking for what they have in common. They have 1, 2, 2, 2, and a 3. A 2, a 2, and a 3. It's what they have in common. 2 times 2 times 3, which is 12. So 12 is the greatest common factor. And that's how you would find it using primes. A lot of you can do it a faster way, but I'm not going to teach it that way because your brain has figured it out. All right, factoring a linear binomial. Okay, binomials are nice to factor because it's basically, it's basically just a division problem. Okay, we're going to break it apart. So you have to ask yourself, this is the first question. What is the GCF of 21 and 28? So you're looking for what do they have in common. I am going to teach this the dividing way, and I'm going to teach it to you the way I do it, which is multiplication. It's a different way of looking at it. Here's the division way. Okay, I find that when students are having trouble with this, division is the way to go. Okay, so what is the greatest common factor between 21 and 28? The answer is 7. So what you're going to do is you're going to separate this into 7 times something. Okay, but to do that, okay, it's even a little hard for me to teach the division way just because of the way I have to write it. It's going to be 7 times something. You need to divide this by 7 and that by 7 because we're going to break it apart. So it's going to be 7 times 3 minus 4, and then W stays with it. Okay, that is one way to look at it. Okay, and that is the factorization. Basically, look, if we distribute this back out, we would get 21 minus 28W. Factoring is the opposite of multiplication. Breaking it apart, putting it back together. Okay. There's another way of looking this is we could break this into 7 times 3 minus 7 times 4w, correct? You see that? And then using distribution or backwards distribution, which is factoring, here we go. You could pull out the 7 because the 7 is in common, and you pull it out, and then you write that. Okay. I personally guess I should put divide each term by it. Okay. I personally think of multiplication. I go, what is in common between 21 and 28? And I think 7. So I put the 7 outside of the parentheses. And then I say 7 times what is 21? 3. 7 times what is 28? 4w. So for me, multiplication forward is easier than division, but I do find that most kids prefer division. Okay. All right, let's try again. Okay. Well, actually, this isn't quite factoring. This is the GCF of two monomials. So now we're looking at what is the greatest common factor between these two? So think about what they're composed of. The way we looked at it with primes. 13 is prime, m times m. That's what 13m squared is. 13 times m times m. 11 is m. 11m to the fourth is 11 times m times m times m times m. So what do they have in common? They have two m's or m squared. Okay, the thing with variables is that if you have, say, y to the third, let's say 2y to the third and 4y to the 10th, okay? 2 is in common with the numbers, correct? Okay. The thing with the variables is it's always going to be the lowest number because this is 3y's, right? And this is 10y's. Okay. Well, the only thing they're going to have in common is that 3y's. They're only going to have these 3y's. Okay. So that's going to be the greatest common factor. And then between 2 and 4, 2 goes into 2, 2 goes into 4, y cubed. Okay, that's the greatest common factor. All right, go on. So look here, looking at 10 and 4. First, take care of the reals. Take care of the real numbers, and then the exponents. Okay, and it has to be like exponents, right? Like bases. Okay, so looking here, between 10 and 4, what's in common? 2 goes into 10 and 2 goes into 4. Okay, if you wanted to split it apart into primes, there you go. The only thing they have in common is a 2. Okay, so 2 is in common. And what's in common between m squared and y? Nothing. So 2 is the answer. Okay, let's try this one. Now you're going to have to try to factor, but in this case, you're going to factor when there is a variable. So you have to ask yourself, what's in common? This is the very beginning, the very first question of factoring. And I will ask that in that very way. I will say, what is the first question of factoring? What's in common? What's in common? What's in common? There's nothing in common between 11 and a 4, right? Okay. What's in common between y and y cubed? It's always going to be the lowest level. There's 1y here and there's 3y's here, but only one is in common. So we are going to kick out that y. Okay. But to know what goes inside here, by the way, if you are factoring a binomial, look, binomial, see, two pieces, you will get a binomial here. And the sign stays the same unless you pull out a negative, then it switches it, but we're not there. Okay. So you say, you divide both of these by y, and you get 11, and you get y goes into y cubed, 4y squared. You can check it. Check your answer. 11 times y times 11 is 11y. Let me say that again. Y times 11 is 11y plus y times 4y squared is 4y cubed. And look, it checks, okay? If you're doing it my way, y times what is 11y? Y times what is 4y cubed? That's the way I think of it. It's the same thing, but different in a way. All right, so hey, 12 and 8, what's in common? Break it apart. We could go 3 times 4, 2 times 4. And look, what do they have in common? 2 times 2, 2 times 2. The only thing they have in common is 2 times 2, or 4. Okay, so 4, we're going to kick out a 4, and we're going to write parentheses. There's going to be 2 pieces, okay? And then we're going to divide this by 4. Okay, so divide this by 4 and this by 4. 12 divided by 4 is 3. You're left with b. Oh, I forgot to pull out the b. Hang on a second. Forgot to check the variable. What's in common with the variable? Okay, so we did the number and it's 4. What's in common between b and b squared? Only 1b. So we're going to divide those by 4b. We're going to get 3, okay, plus 2. 8 divided by 4 is 2. B squared divided by b is b. And you could check it. Check it. 12. Forgot to put the dang b on the outside again. Let's try that again. Let's put that b. Whatever you divide by needs to go there. Okay? Sorry. 12b plus 8b squared. Do you see why it's really important to check, though? See, I am living proof of why you need to check things. All right. Now we're going to factor a larger polynomial by grouping. Okay. Grouping is its own kind of factoring. And it kind of feels not mathy because you're not really thinking about it. It's kind of a process. And the process is what you have to memorize. I will allow you to write the process down. It's also called the AC method in case you decide to look it up. You can look it up on the YouTube or internet as factor by grouping or factor by AC method. Okay, but here's the way it works. You do factor by grouping with quaternomials. Quaternomials? Look at, there are 1, 2, 3, 4 terms. That's when factor by grouping works. Okay, when you see a trinomial, not going to do it. When you see a binomial, not going to do it. It's factor by grouping is for specifically for this. And then what you're going to do is you're going to group these two together. You're going to be very careful. Actually, you know what? I like a better way to show it. You have to be really careful with this sign right here, this when it's a minus. So I'm going to be really careful. I like doing it this way because look, we are looking at, this is forcing us to look at these two together and these two together. Factor by grouping means you group 2 together and 2 together. Okay, so step 1, okay, is to basically group into pairs. I'm sorry if that, I hope that makes sense. This is a pair and that's a pair. 2, factor each. Oh, maybe I should, instead of pairs, maybe I should use math term, like into binomials. Get it? That's a binomial and that's a binomial. Factor each binomial. That's the second step. So you look here and you go, what do they have in common? They have a y squared in common. So y squared times, divide this by y, and you're going to get 3y plus, divide this by y squared, divide this by y squared, and you're going to get 2. And then you ask yourself, bring down the plus, what do they have in common? They don't have a y, but 6 and 4 have a 2 in common. So we put the 2 on the outside. We divide 6y by 2, and we get 3y. We divide 4 by 2, and we get 2. Okay, and if it is factorable by grouping, these two should match. Okay? And this is the hardest part about this method. Most people do it without understanding what they're doing. They go, oh, these match. I'll put them together here and then write what's left. Literally, that's how it feels. You're like, ooh, they match. Put it here. What we're really doing, you guys, is actually factoring. Check it out. The common factor is 3y plus 2. We're putting it outside the parentheses, and we put what we multiplied it by. Look, 3y plus 2 times y squared, 3y plus 2 times 2. We hardly ever do that kind of multiplication. It doesn't really happen. So we're not that familiar with it, and it's a kind of a big mental jump. But if they match, okay, we're going to factor that out and put what's left right there. Okay? And then factor each binomial, and then factor again. I don't know if there's anything better than that. You know what? This is not the AC method. The opposite method is called that. This is just factor by grouping. I'm not erase that. The AC method is for actually factoring a trinomial. Okay, factor again. Okay, and by that I mean like the way it's going to look is you'll have some number A times some grouping, I'll put a star, and then maybe plus B times star. And then what you do is you put whatever that is times A plus B. If that confuses you, don't worry about it. It's more mathy, but it's okay. If you don't get it, it's fine. As long as you get this. We'll try again. Okay, factor by grouping again. So what you do is you draw that staircase, right? Group the two binomials together. Ask yourself, what's in common? W squared is in common. So divide both of these by W squared, and you're going to get W plus 2. We're going to carry down the plus, and then what's in common between 3W and 6? It's 3. Divide each of these by 3. You're going to get W plus 2. Oh, look, they match. So now you're going to put that one here, W plus 2. We're going to factor it out and then put what's left, W squared plus 3. And that is your answer. Okay, next. Okay, here's another one. Okay, the reason why I did so many, and you can zap it forward if you don't need this now, if you feel like you got it. I did a lot because I feel like 3 is usually the minimum, or kind of like the nice number for somebody to get it. Okay, so take a look here. I think I didn't. Okay, they didn't put a minus sign here. When there's a minus sign here, then it turns into a dangerous problem, and I couldn't find one. So I'm not sure if they're not giving it to you. But if you end up with a situation where they're almost the same, it has to do with this, and there's a minus sign here. That's when you have to factor out that negative. Maybe we'll hit it here soon. I tried to grab them, but we'll see. Okay, what's in common between 12 and 16? The greatest common factor would be 4. What's in common between W cubed and W squared? W squared. Okay, parentheses, divide those by 4W squared, and you're going to get 4W minus 3. Plus, bring down that plus. What's in common between 20W and 15? 5. And then 4W minus 3. Dividing it by 5. And then look, they match. 4W minus 3 times 4W squared plus 5. Okay? All right, and that's your answer. Next. All right, now we're getting into factoring. Okay, this is actually supposed to be review, and I really hope it is. If it is not review, we will work in class very hard on this, okay? But this is a quadratic, okay? When you see something with a square, we call it a quadratic, okay? What that means is that it describes an area, okay? What it really means is that it's two things multiplying by each other, and that forms a rectangle. Now, you may not get that right now, but any two numbers multiplying by each other can be illustrated by a rectangle. And so this is two things multiplying by itself, so to speak, describes a quadratic. Do you need to know any of that? No, but it's good to know. Like it's good to know in case you can trigger that, like, okay, I'm going to break it into two pieces. We are going to break into two pieces. And what's interesting is a quadratic looks like this, right? When we break the two pieces, guess what they are? They're actually linear. They're like lines. So a quadratic is a line times a line. Again, don't need to know that, but I think it's kind of funky. All right. So here's what you're going to do. The first question you're going to ask, I'm going to switch colors because all of that is not necessary, just kind of extra knowledge. The first thing you're going to do is ask, what's in common? I want you to get used to asking that question because they're never going to give you these easy ones. Okay, eventually we're going to get some hard stuff that has stuff in common. This one doesn't. Nothing's in common. So then the next question is, what is the degree? Okay, or what kind of polynomial it is? Okay, how many terms is the best way to write that? How many terms? This is just for you to look. Okay, this one is a trinomial. The answer for this one is a trinomial. It's a quadratic. We know that quadratics break into this. Now, I know I'm telling you more, but the reason why is because the unit coming up is going to be the most killer unit ever on factoring. And all of these questions that seem kind of stupid right now are going to be really important then. Okay, so I want to build them into your repertoire, or in the back of your brain plane. Okay, all right. So then what you're going to do is we're going to factor this, kind of thinking of it as backwards foiling. And I'm going to remind you real quick what foiling is. Remember x plus 2 times x minus 3? So you go x squared minus 3x plus 2x minus 6, x squared minus x minus 6. See, it's a trinomial. We multiplied two lines, so to speak, x minus 3, x plus 2. We multiplied two binomials, and look what we got, a trinomial. Now we're trying to do backwards. This is what we're trying to learn how to do today, okay? And actually, it should be a repeat. Hope to God it is. So you say to yourself, what two things multiply together to get z squared? The answer is z and z. Because the first term, this comes from this first two multiplying by each other. Okay? We know the last two are going to come and they're going to multiply to get 12, right? 2 times 3 is 6. So you see the first and the last in FOIL are set. Those are, they have to be in there. They are in plain sight. It's the oi that screws us up. This is the hard one. Don't look at the oi to try to figure out what's going to go in here. These two numbers multiply together to get z squared. These two numbers multiply together to get 12. So, and negative 12, by the way. So what we do is we write them down on the side here. We list the factors. And yes, we list the factors. We don't try to be brilliant unless, you already have done it a million times and know it in your head. Those are the factors of 12. Okay? That gives you a positive 12. But we could list it in multiple ways. I'm thinking with algebra 2, you guys will be ready to just list it here and realize one of these guys has to be a negative, right? To get a negative 12. We want to, okay, here's the question you next ask, okay? I just realized now I should do this. If it's a trinomial, okay, we should try to factor it. That's the next step. Try to factor. Okay? All right. So look, the next question we ask here is, how can I make a negative 4? Okay? And the answer is with 2 and 6. You could do a negative 6 and a positive 2. They add up to 4. So the numbers that multiply together to get 12 have to add to get the OI. Okay? So we're going to go with plus 2 minus 6. So check it out. Check it. Z times z, z squared. It checks. Okay? Z times negative 6 is negative 6z. 2 times z is plus 2z. 2 times negative 6 is minus 12. Z squared minus 4z minus 12. Do I need to check it? Yeah, unfortunately, you actually do. Okay? Because a lot of times you screw up. And signage is everything. So the idea is that these questions come first. Okay, this is before you factor. Then to factor a trinomial, you list the factors, and you are looking for the combination that multiplies to get the last, but adds together to get the middle term. Let's try this. So here we are, okay? First thing, anything in common? No. Okay, how many terms does it have? 1, 2, 3. It's a trinomial. It's a quadratic. Oh, maybe we can factor that. And that's what you think. Oh, maybe we can factor that. So let's draw the parentheses. Okay, by the way, these parentheses make me happy. I always draw them first because I know I can fill them. So what times what equals y squared? Y times y. Okay, and then you have to look at the last one. What times what equals 21? 1 times 21, 3 times 7. How can I get a negative 10? Now, this plus, what does that mean that that's a plus? You guys, y times y is y squared. This times this has to equal 21, right? Whatever's here and whatever's here has to equal 21. Well, this plus tells you that the signs are the same. They're either plus plus or minus minus, okay? Because a negative times a negative is a positive, and a positive times a positive is a positive. So this will tell you what sign they are. Because a negative 3 and a negative 7, negative 3 and negative 7, when you multiply them, they equal positive 21. And when you add them, you get negative 10. So it's minus 3, minus 7, or minus 7, minus 3. It doesn't matter. Check it. I'm going to check it always in a different color if I remember. Y squared minus 7y minus 3y plus 21. Combine that. Y squared minus 10y plus 21. And there it is, right there. Okay, next. All right, let's take a look again. Anything in common? Nope. Okay, how many terms does it have? 3. It's a quadratic. Okay, let's try factoring it. Y and y, because y times y is y squared. List the factors of 33. Now look at that minus sign. Okay, we're looking for 1 times 33, 2 and 3 times 11. And that's it. Can I get an 8 from 3 and 11? Yes, I can. Okay, but I need one of them to be positive and one of them to be negative. Because look, the only way we can get a negative 33 when we multiply is one of them has to be positive and one of them has to be a negative. How can I get a positive 8? It has to be a positive 11 and a negative 3. because when I add plus 11, negative 3, I get positive 8. So plus 11 minus 3. And let's check it. Y times y is y squared. Y times negative 3 is negative 3y. 11y minus 33. And that's plus 11y. Okay, like terms, y squared plus 8y minus 33. Is that what we wanted? Check. It is. And that's it for the easy factoring. The next factoring video, it has all the hard stuff on it.